Greetings, welcome once again. We are back with results-oriented preparation, and today we are looking at probability. Okay, this is an introduction to probability. We'll be doing a simple stuff with the explanations, definitions, and then we'll go on to Venn diagrams. Okay. Now, in probability, we concentrate on a couple of things. And the first thing that you need to know in probability is what is known as an event. All right. What is an event in probability? Probability, an event is an activity that has outcomes or results. This is an activity that has outcomes or results. All right, so we're looking at outcomes, and there has to be something that happens. The activity has got specified outcomes or results, or expected outcomes or results. Okay, let me give an example of, for example, let's say we look at rolling a dice. All right, rolling a dice. We know that a dice has got 6 sides. Okay. Now, if you roll a dice, what are the chances that an even number or on the dice is the event given? Okay. Rolling on even numbers, an even number on a dice is an event. Okay. Let's say you want to say even number. Okay. Now, if you roll the dice and the chance that it is an even number, okay, we'll call that an event. Okay, so if the dice falls on an even number, that's the event that we're looking at. Or alternatively, if we're looking at odd numbers, if you throw a dice, what is the chance or the outcome or the results that it will be an odd number? So that will be the event. Okay. So the outcome or the result is the even number. The activity is the rolling of the dice. The activity is rolling the dice. The outcome or the results is the even number. Okay. And then also there are many possible outcomes. Now, if you're looking at the possible outcomes of rolling a dice, the possible outcomes, these are the possible outcomes. The possible outcomes for rolling a dice is that it will be a 1, a 2, a 3, a 4, a 5, or even a 6. These are the possible outcomes. So when we're looking at the possible outcomes, we're talking about all the outcomes or the results that can come through the activity of rolling that particular dice. So all these are the possible outcomes, because we do not know yet. It's not cast in stone that every time you roll it's going to be a 6 or it's going to be a 1, but there is a possibility of outcomes. That possibility is the probability of something happening, and then that is the event. Okay, now we're going to look next at, let's define next what a sample is. Sample space. Okay, and then next we are looking at a sample space. A sample space. Okay, now when we are looking at a sample space, what we're looking at the set of all possible outcomes. Now, the sample space is the set of all possible outcomes. Okay, let's say, for example, we've got a coin. All right, what are the possible outcomes? All the possible outcomes when you toss a coin. When you toss a coin, the possible outcomes or the sample space is either head or tail, right? It's either head or tail. Okay, and then the event, if we want to find the event from there, the event can be, is it head? All right. Okay, let's say the event that it will be head. The activity is tossing a coin. The event is that it will fall on a head. The sample space is all the possible outcomes, which is head and tail. All right, head, tail are the sample space, which is all the possible outcomes that we have there. Okay, so what I want us to look at with relation to this, to better explain this, we're going to look at what are known as Venn diagrams. Okay, we're using Venn diagrams to try and simplify probability. So we've got Venn diagrams. All right. Now, in a Venn diagram, we've got a couple of things that we need to take note of. The first thing that we take note of in the components, okay, the components or composition of a Venn diagram, meaning what the Venn diagram is made of. One, it is made of what is known as the sample space. The sample space. Now, the sample space in most other textbooks, it will always be referred to as the universal set. Now, the universal set has got all possible outcomes. Okay, now, since sample space is the same as universal set, and it comprises of all possible outcomes, and usually it is rectangular in shape. It is rectangular in shape. Okay, so it is the outward part of a Venn diagram. It is rectangular in shape, and all the possible outcomes are found in the sample space. Okay, and then we've got the circles. All right, and the event stands for is shown in the form of circles inside a sample space, inside sample space. Hey, what's happening? Okay, sorry for that. Inside sample space S. All right, we've got an event, and usually these are in the form of circles. All right, these are in the form of circles. Okay, and then we've got also the third, which is the intersection. The intersection represents the where, for example, the circles overlap each other. We will have the intersection there. So this is where the outcome where both events will occur. Okay, it shows which outcomes belong to both events. So outcomes belong to both events. Okay, or it may be three events, whatever the case might be. Now let me show an example of this in the form of a diagram. Okay, now our Venn diagram will be in this format. Okay, so we say that this rectangular shape there is called the sample space, so we label it as S. All right, we label it as S. And then inside, we've got two events. Let's say event A. This is event A. This is event B. Okay? So we've got event B. And then here you've got event A. Okay? Alright. And then here, this shaded part here is our intersection. Okay. Now in the intersection, what happens is in the intersections, these are the outcomes that belong to either A and B. They belong to both A and B. So here, events in A, then events that belong to event B, outcomes belong to event B, outcomes belong to event A, and then in the center where the two meet, this is outcomes that belong to both A and B. So that will be a simple representation of a Venn diagram. Remember, we've got the sample space, and then we've got the events depicted in the form of circles. And then we've got the intersection, which shows outcomes of both A and B that belong to both those particular events. Okay? So what we're going to do is we're going to look at an example there, and then probably calculate a couple of things and show exactly how we will calculate the probability of particular events taking place there. All right. So in our Venn diagram here, we are looking at integers from 1 to 10. Okay. So we've got a diagram like so. This is our Venn diagram. So this is our S, our sample space there, which is S. And then next we will have inside there, this is S. In other books where they'll say universal set, they'll put something like this, something like an E, all right? But for now, we can even put sample space, it's okay. So it's either this universal set or the sample space, okay? And then we've got A there. Okay, this is event A. And then we've got event B on the other side. Event B, okay? Now in our sample space S, sample set is a set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? The numbers 1 to 10. That is our sample space. Okay? So all these numbers have to be within that particular sample space. Okay, now to decide what goes into A and into B, then we've got A being all, not all, but prime numbers. We've got the prime numbers 2, 3, 5, and 7. All right? Those are the prime numbers there. And then we've got B. B is made up of even numbers 2, 4, 6, 8, and 10. All right? Those are the even numbers in B. So let us attempt to fill those up. Okay? So we've got A, there is 2 in A, there is 3, there is 5, there is 7, okay? But if you take note there, you will see that there is 2 again in B. So these 2 here automatically goes right here in the center, because 2 is the intersection, which means it belongs to both A and to B. Okay, so then we will look at the others, which is B. We've got also 2, 4, 6, 8, and 10. But we still have got one number that is not accounted for there, which is 1 and 9. Two numbers actually, got 1 and 9. Meaning that 1 and 9 are still in the sample space, but they are not part of A nor B. Okay? So we put our 1 and 9 in the sample space, but not in either A or B. Okay? And then the question says, determine the probability of event A happening. All right, the probability of A happening there in the sample space. What is the probability of A? Now, what we need to do to find the probability of A, we need to know how many items do we have. We've got 4, and out of the total, so we make a fraction of the sample space. So probability of event A happening is equals to 4 over 10. You see that? Because we've got 1, 2, 3, 4, and then all of them are 10 elements. So you've got 4 elements out of 10 elements. But because this is probability, you need always to express that in its simplest form. So this will be 2 over 5. If 2 is a factor, then 4 divided by 2 is 2. 10 divided by 2 is 5. Okay, that was number 1. And then number 2. Number 2 says determine probability of B. What are the chance? What is the chance that B will take place in a set? Okay, so event B is, we look again at the number of items is 1, 2, 3, 4, 5. We've got 5 elements in B, all right, and the total is 10. So this will be 5 over 10, and 5 over 10 is equals to half. Okay, and then we go to 3. Okay, in 3 we are looking at what is the probability of event A and B. Now A and B always, sorry, I forgot the bracket to close off. Now A and B there is the intersection of A and B. All right, what's the probability of that? We've got only one element that fits in there, so it's going to be 1 over 10. All right, and then the last one, we've got P. For we've got P, A or B. All right, now this one here is going to be to find that we're going to say PA plus B, PA plus P event B, all right, and then minus P, A, and B. All right, so we've already found what our A is. Our A is 4 over 10, so you put 4 over 10 there. 4 over 10 plus 5 over 10 plus 5 over 10 minus 1 over 10. All right, now 4 over 10 plus 5 over 10, the common denominator is 10. 4 plus 5 is going to be 9 over 10. 9 over 10 minus 1 over 10 will give you 8 over 10. So our answer there for A or B is going to be 8 over 10. Now, please always remember that when we get A or B. What A or B means that first you need to add the probability of event A and the probability of event B taking place, and then subtract from that the intersection of A and B. That will give you A, which is 4 over 10 plus 5 over 10 for B, minus 1 over 10 because A and B is 1 over 10. So that will give you a common denominator of 10, and then we've got 4 plus 5, which is 9, minus 1, which gives you 8 over 10. Now remember, this is merely the introduction to our probability. There's still a lot that we are yet to discover in this topic. So please make sure that you've got as many questions as you can write from the beginning, so that as we proceed, then it becomes easy for you to understand the rest of the items. And I hope you really enjoyed this presentation. We'll meet in the next lesson.